Welcome to another video. As you can see from the title of this video, today we will be explaining the rate and extent of reactions topic in physical sciences, the chemistry part. So my aim is to try to explain this topic as quickly as possible with the highest level of ease. So let's get right into it. So let's start off with the definition of the rate of a reaction. So what is the rate of a reaction? So the rate of reaction is defined at, what it does is that it indicates, the change in the concentration of the reactants or the change in the concentration of the product per unit time, right? So that's what the rate does. It tells us about the change in the concentration of the reactants or the products, right? So how do we then calculate this change? So we use this formula, and normally you'll hear us speak of the average rate. So it can either be the change in the concentration divided by the change in time. So the change in the concentration, it can be the change in the concentration of the reactants. So that R over there just stands for reactants. Or it can be the change in the concentration of the products. So we can use concentration to find the average rate, but there are other formulas we can use as well to calculate average rate. So you can also use the change in volume of a specific substance. For example, maybe there's a gas forming in your reaction and you can figure out what the rate of the entire reaction is by just looking at the volume that is formed of a particular substance. You can also use the change in the number of moles. So again, remember, this applies to reactants or the products, right? So it really depends what information you're given in your graph or in the question, and you use that to figure out what the rate is. So if you were using concentration to calculate what the rate is, then the unit would be decimeter or mole per decimeter cube per second, right? Because rate is related to time, how fast. If you're looking at volume, then it would be the unit for your rate would be decimeter cube per second. If you're looking at number of moles or the change in the number of moles, then that would be moles per second. So it really depends what information you're given, and you use that to calculate the rate. Wonderful. Another important thing that you need to notice or you need to know is that sometimes the average rate is referred to as the gradient. So we'll hear us speak of the gradient or the slope. All right, and that's going to be important. So when you look at the slope, for example, of a given graph, maybe it's a concentration versus time graph, maybe it's a volume versus time graph, maybe it's a number of moles versus time graph, that tells you the gradient of that graph is the average rate. Wonderful. So let's look at an example here to better understand what is going on. So here I've got a concentration versus time graph, and I've got two things forming. So let's think of a hypothetical reaction. Let's say A plus B react to form AB. All right. So the products here represents the concentration of AB, and the reactants represents the concentration of A and the concentration of B. So what is happening here? So for our reactants, what we can see is our reactants start off at a certain value, high value or high concentration of the reactants. So we start off with a high concentration of A and B, while our products at initial time of 0 at the start of the reaction start at 0, right? And what's happening? As time continues, the reactants are being used up, so they decrease in the concentration, while simultaneously the products are being formed, so they increase in the concentration. That's essentially what happens when a reaction is happening. When a reaction happens, the reactants are being used up and the products are being formed. And this is what this graph illustrates for us here. I wrote down a statement here which is quite important. So the statement says that most reactions start off quite fast and slow down as time goes on. So therefore, the rate in the beginning will always be faster than the rate towards the end. So what does that mean for us? That means that between time 0 and, for example, time 1, if you're looking at the products or even the reactants, the reaction is happening quite quickly. It is fast. So if we were to calculate that rate or that gradient between in those 2 points, we would get a very high value, right? Because the reaction is starting off. And as time goes by, let's say between time T1 and time T2, the reaction slows down. And the reaction slows down, the rate slows down. So if we're going to look at the gradient between that point and that point, it would be much smaller than the gradient that we'd get between T0 and T1. Reason is because after T1, the reaction starts to slow down. And we can see this if we try to draw the slope, right? So if I pick that point over there, I'm focusing on the products graph, and I try to draw that slope, and I pick point 2 over there, and I try to draw that slope, I can see that this one is steep, right? It's much more steep. Is more steep, sorry about that. So it's more steep, while this one over here is less steep. Okay, and then what that tells us is the gradient here is faster or higher than the gradient over there, which means the reaction rate is faster in the beginning and then it slows down as time continues. I also indicated here that if you want to figure out what your dependent and independent variable is for a reaction, you will be asked this by the examiner. You just look at your axes. So whatever's on the y-axis is always your dependent variable, and whatever's on the x-axis is always your independent variable. Most of the time, this will be time for you, okay? This is in the concentration versus time graph, okay? Wonderful. Now we cannot talk about rate of reactions without taking a look at the collision theory. So the collision theory is important because it helps us understand how reactions happen, okay? So this theory says to us the reactions happen because particles are colliding, all right? So I've got a beaker here on the right-hand side, and what this theory is telling us is that reactions happen because these particles are colliding. So this particle will collide with that particle or that particle, or whatever, but these particles are busy moving around and they collide. And as a result of those collisions, therefore, we have a reaction happening. So the collision theory helps us to figure out how we can improve those collisions, because the more collisions we have, the more effective collisions we have, therefore, the higher the rate of reaction. And you'll be learning this now. So there's 3 things that we speak about under the collision theory. The first is the frequency of the collisions. Okay, so how often are the particles colliding? This is dependent on the number of particles per unit volume. So the number let's say reactant particles per unit volume. Okay, so how often the particles collide is dependent on how many particles you have. So what does this mean? This means that if you've got maybe say this fixed amount of particles, you're going to have only a certain number of collisions. Okay, but say now I increase the number of particles. I increase the number of particles. Because I've increased the number of particles, I'm obviously going to have more collisions because there are more particles present. All right? So the frequency of collision is related to the number of particles per unit volume. Number 2, under the collision theory, we have to talk about the energy of the particles. So it's not enough for particles just to collide, but they have to collide with what we call sufficient energy, enough energy. Because we learned in grade 10 and in grade 11 that there is a minimum amount of energy required in order for a reaction to happen. And we call that the activation energy. So, under energy, we always speak about temperature. Right? So we define temperature in chemistry as the average kinetic energy of the particles. Okay? The average kinetic energy of the particles. So, if we wanted to increase the energy of these particles, what we would do is that maybe we would add a heater there at the bottom, a Bunsen burner at the bottom of this beaker, and would increase the temperature. Because when we increase the temperature, all the particles increase in kinetic energy. All right, so that's the first thing. So when temperature is increased, okay, the kinetic energy of the particles increases. Okay. Let's move this a little bit to the right. Okay. And then why is this beneficial? So why is it beneficial for us that the kinetic energy of these particles increase? Because what you'll realize is that even though you have a lot of particles, if the particles are moving very slow, it takes too long for it to bounce there and bounce there and bounce there and bounce there, which means you're going to have a slow rate. But when you increase the energy of the particles, you're going to have particles moving very rapidly like that. And the more rapidly they are moving, the more collisions we have. Remember, the goal of the collision theory, we want to have as many collisions as possible. So the more energy the particles have, the more they collide, And we increase this energy by increasing the temperature. Right? So the more, when temperature is increased, the kinetic energy of the particles increase as well. And therefore the particles move more rapidly. Okay, and therefore and collide more often. And that's what we want. We want the particles to collide as often as possible. Wonderful. The third thing that is related to the collision theory is the correct orientation. So it's not enough that particles are colliding, and it's not enough they're colliding with enough energy, but they also need to collide in the correct orientation. Right? So orientation refers to the position. Okay. So the particles Wonderful. So these are the three things that are related to the collision theory. How often are the particles colliding? How much energy do the particles have when they collide? And are they orientated correctly? So in summary, particles must collide in order for a reaction to happen. Right? So in order for any reaction to happen, the particles have to collide. That's how we get a reaction. And only particles with kinetic energy that is either greater or equal to the activation energy. Remember, the activation energy is the minimum energy required in order for reaction to happen. So those particles that have a kinetic energy that is greater or equal to the activation energy, those particles collide effectively. Lastly, only particles with the correct orientation result in a reaction. So this is a nice summary of the collision theory. The fourth summary, which is actually the most important thing, and what we need to take note of, is that the reaction rate, so how fast our reactions are happening, is directly proportional. So this symbol means directly proportional to these three things. It is directly proportional to the number of collisions. It is directly proportional to the number of particles with kinetic energy greater or equals to the activation energy. The reaction rate is directly proportional to the particles with the correct orientation. So what does directly proportional mean? It means that as you increase any of these three values, you also increase the rate of a reaction. And if you decrease any of these three items, you're also going to decrease the rate of reaction. So this answers the question, how do I increase the rate of reaction? I either increase the number of collisions, I increase the number of particles with kinetic energy greater or equal to the activation energy, or I increase the number of particles with the correct orientation. Increasing any of these three things will increase the rate of a reaction. Beautiful. Given this, now we can talk about the factors that affect the rate of a reaction. And what you will notice that what all these factors do is either one or all of this. So it will either increase the number of collisions, or it will increase the number of particles with kinetic energy greater or equal to the activation energy, or it will increase the number of particles with the correct orientation, or it will increase all three at the same time, because we want to have a faster reaction rate. Now, the first factor that affects the rate of reactions that we need to talk about is the nature of the reactants. So I've got this statement here that alkali metals, the reactivity increases as you go down the group. So I've pasted a picture of the periodic table, just a copy of the alkali metals. So the alkali metals are all the metals that are highlighted in the light blue. So your lithium, your sodium, your potassium, rubium, cesium, and so on, right? All of those are your alkali metals. So what this statement is telling us is that as you go down this group, the reactivity increases. So if I were to compare, for example, lithium to potassium, for example, I would say potassium is more reactive than lithium. That's what this statement is telling us, all right? So this is important because you will get questions where you're comparing two different reactions where maybe, for example, in one reaction you use lithium and in the different reaction you use potassium, and you want to figure out which one is more reactive, okay? So the more reactive you are, the higher the reaction rate, okay? So the reaction rate we can put it this way, is directly proportional to reactivity. So the more reactive you are, the higher the reaction rate. Beautiful. The next factor that affects the rate of reaction is temperature. So I'm going to start off straight off the bat and just say to you that the reaction rate, right? So the reaction rate is actually directly proportional to temperature. So what does this mean for us? This means if you increase the temperature, you increase the reaction rate. All right? But how? Why is this true? Why is this statement true? And this is what we are going to attempt to explain, right? So we know that when temperatures increased, at the end, the rate of the reaction will also increase. But how does this happen? This happens because when you increase the temperature, you increase the number of particles with kinetic energy greater or equals to the activation energy. Okay, so in essence, you've got more particles with sufficient energy. And if you've got more particles with sufficient energy, you will have more effective collisions. And the more effective collisions you have, we already have that statement here, right? So you've got more effective collisions per unit time, and the more effective collisions you have per unit time, therefore the rate of the reaction will increase. So the opposite is also true, right? So if you decrease the temperature, you actually decrease the number of particles with kinetic energy greater or equals to activation energy, and therefore you've got less effective collisions per unit time, and therefore the rate of reaction will decrease. So it's literally just the opposite. So going into the exam, just study the one, and if there's a decrease in temperature, you know, you're just going to swap out the words. All right, when concentration is increased. So the third factor that affects the rate of reaction is concentration. So again, the rate or the reaction rate is directly proportional to concentration. Okay, so when you increase the concentration of a reactant, right, you actually increase the rate of the reaction. So the reaction will happen faster, right? So why is this true? When concentration is increased, what you do is that you've got more particles per unit volume, right? So you've got more particles per unit volume. So it goes back to that collision theory that we talked about. The more particles you have, therefore you're going to have more collisions, and that's what we want. So the more particles you have, the more effective collisions you will have per unit time, and the more effective collisions you have per unit time, therefore the higher the reaction rate. And the opposite is true, right? So if you decrease the concentration, you'll have less particles per unit time, less effective collisions per unit time, and therefore the rate of reaction will decrease. So knowing one side of it will help you know the other one. The fourth factor is the surface area. Right. So surface area is directly proportional to the reaction rate. Right. So if you increase the surface area, you also increase the reaction rate. So how do we explain this to the examiner? So when a solid reactant is divided more finely, what happens? There is a greater surface area, so SA there stands for surface area, for collisions to occur, right? And because there's a greater surface for collisions to occur, you will therefore have more effective collisions per unit time, and therefore the rate of the reaction will also increase. So this explains why tablets, for example, tablets like pills, why powder is more effective than tablets, right? Because with tablets, you've got a smaller surface area, but with powder, you've got a greater surface area. And the greater surface area you have for collisions to occur, you've got more effective collisions per unit time, and therefore the rate of reaction will also increase. Okay? Third, but definitely not least, third, it's the last one, the catalyst. Right? So what happens when you use a catalyst? So when you use a catalyst, the activation energy, EA, so activation energy, is lowered. Right? And when the activation energy is lowered, what then happens is that you have more particles with a kinetic energy that is greater or equals to the activation energy, right? Because you've kind of lowered the standard, and that's what a catalyst does. It lowers the standard. So because the activation energy is less, you've got more particles that have a kinetic energy that is sufficient, right? Sufficient energy. And therefore you will get more effective collisions per unit time, and therefore the rate of reaction will increase. Wonderful. So these factors and these points is what you want to memorize and hash back to the examiner. They're related to, these are the factors that affect the rate of reaction, and these are the bullet points that you will use to answer any question depending on what you're testing. Sometimes you'll be testing temperature, concentration, the surface area, or a catalyst, or the nature of reactants. And these are the statements that you will use to explain to the examiner why is it the rate increases or decreases depending on what is happening. Wonderful. I hope you found this video impactful. Please remember to subscribe, to like the video, and share it with your friends or classmates that also might benefit. Thank you for tuning in, and I'll see you in the next one.